Hi everyone, welcome to this mock interview session on linear regression and time series. So what we'll be doing is I'll be asking you a bunch of interview questions based on linear regression. So if you know the answer, just raise your hand, and I'll just ask you to please tell the answer. And if you think like you have, so let's say someone told the answer and you think you have a better answer than the person, please again can just ask me if you want to tell the answer, just raise your hand again. And see, the thing is, we are trying to get the best of the answers. So don't think, oh, even if I raise hand, it might be offend, like the other person might get offended. So don't think like that. We are just trying to help each other out in practicing all this interview questions. So like the first question is like, what is a linear regression, and what are different types of linear regression?
Yeah, should I go ahead?
Yeah.
So linear regression is a statistical method where we try to find the relationship between the dependent and the independent variable. It uses the method as a best fitted line in the data. And there are various type of linear regression. One is a simple linear regression where we use only one variable, and there is a multiple regression where we use a multiple variables, more than one variables, to find the relationship between the dependent and independent variable.
Okay. Okay. Anyone else?
Do you want me to tell you the other types of regression as well, or
No,
only
no.
the?
No. I'm just trying to understand. Anyone else who wants to answer this? Maybe Siddharaj, you wanna go ahead? Yeah.
Yeah, so linear regression is basically understanding how building a model to see how a few set of variables can help you understand the relationship between them and the dependent variables.
Okay. Okay. So yeah, and explain its type. Any idea on that?
Um, Sorry, should I go ahead?
Yeah. Yeah. Please go ahead. Yeah.
Yeah. Uh, I think there's OLS like regression, and there's also weighted least squares or generalized least square regressions.
Okay. Okay.
Oh,
So
actually, I think I had. Oh, I think we were missing out on one more, the maximum likelihood method, probably, and that is basically uh, it basically tries to maximize the likelihood of parameters when we are trying to fit the model.
so where do we use the concept of MLE? Here.
Uh, I'm not sure about the details of that particular modeling technique.
Yeah. Okay. So ordinary least square. Do you know what's the difference between ordinary least square and maximum likelihood estimator?
Yeah, so for OLS, we basically tries to minimize the sum of squared errors. But for Emily, like I mentioned before, we try to maximize the likelihood objective function, so that the parameters try to match the real world modeling equation that we're trying to figure out.
Yeah, so that's what ordinary least square OLS is more towards, basically, if you see how we are calibrating of how we are finding the coefficients of a linear regression of a ordinary least square is by minimizing the difference of the error, you know, and
Yeah.
I guess in linear regression. So I guess, and if you see in Python, there are different one is the OLS, and then one you can import from sklearn, if I'm not wrong. So I guess
Hmm.
sklearn one uses the concept of maximum likelihood estimator, and the OLS ordinary least square actually uses the concept of this least square, the difference between calculating the difference of the least square. So
Yeah.
yeah. So yeah, I guess all the answers are right. Linear regression is nothing but a statistical way to find the linear relationship between dependent variable and independent variable. How it does is by finding a line of best fit, which is also called a straight line. And then again, different types. It's like simple linear regression, multiple linear regression. So Siddharth, what you said, uh, you said weighted least square regression. Then you mentioned other techniques. So those actually come into multiple linear regression techniques. Like if you see lasso regression, rigid regression, elastic net regression, those are nothing but a part of the multi-linear regression family. But you guys were spot on. Yeah, just wanted to make sure you understand these two differences, the OLS and the MLE difference. Now, what are the assumptions of linear regression? Yeah, just raise your hand. Yeah, just raise your hand. Yeah, Akshay, please go ahead. Yeah.
Okay, so there should be linearity between the variables. Then there shouldn't be any autocorrelation
Mhm.
between the residuals. There it should follow homoscedasticity. That means the error term should be constant. Then it should not have multicollinearity, and then it should follow normal distribution.
What should follow normal distribution?
I mean, it's an assumption that linear regression follows normal distribution. Is that
Uh,
right?
are you sure that linear regression follows normal distribution, or is it something else that follows a normal distribution?
The residuals.
Yeah, right. That's the
Yeah.
correct answer. So if you say
All right.
linear regression follows normal distribution,
Okay.
then linear regression will be a bell-shaped curve.
Right.
But linear
Okay.
regression is a straight line, right? So
Right.
anyone, I guess the answers were on point. Anyone wants to answer, like anyone wants to go ahead and try this answer? Siddharaj, yeah. I see your hands raised. Yeah.
I just had one question. So I've read that the no multicollinearity assumption.
Mm,
We assume that there shouldn't be the assumption says that there should be no perfect multicollinearity.
mm.
So is it right if when in case if there's maybe 90 or 95% of multicollinearity present in your variables, then it's okay to use those variables, but there shouldn't be any perfect multicollinearity. Is that right? Or
So the way it works is there should be no multicollinearity between the independent variables, right? So let's say you have two independent variables x1 and x2, and those are like highly multicollinear. Let's say 95% multicollinear. So what it essentially means, when how will it have 95% when almost the data is almost the same, right? That's why it is giving high multicollinearity. So when the data is almost the same and only 5% of the sample data is different, then of course it makes sense to drop one variable. Why? Because when you are including two variables, right, which has almost like 95% of the same data, you're also increasing you're increasing one extra variable, which will reduce your R square and your adjusted R square. So that's why like it will reduce your adjusted R square. Sorry. So that's why it's better to drop that variable.
okay.
I,
So
yeah.
is there like an acceptable level of multicollinearity that we can consider?
It
Or if it is even a little bit, if there's even a little bit of multicollinearity, should we drop the variables?
No, it depends a lot on what data are you working on. Like let's say there's this model which I was working back in India, and it was using we were building a regression model, and it was using both treasury 1 month, 3 month, and all the other maturities of treasury. Now, even though if you see the correlation between treasury 3 month and 1 year, the correlation is way too high, but still we had to use those because those are required to understand the yield curve. So that's why it depends a lot on the use case, what you are trying to figure out. Let's say take an example of credit risk. When you're building a credit risk model, you might have FICO. So I was working on a data set, and this is again back at PwC, I guess. So there was a FICO score low, FICO score high. 95%, and there was a 95% correlation. So we had to drop one. So what we dropped was FICO score high, because for us what mattered was how low the FICO score went. So I'm just trying to say it depends a lot on case to case and what situation you are working on. So, but yeah, you guys are on point. So the next question is how to measure the linearity between dependent and independent variable. Like the first assumption that says, there should be a linear relationship. Yeah. So how do you measure that linear relationship? Yeah.
Using the correlation coefficient.
Okay. Yeah, that is right. Uh, so like what correlation coefficient?
It's denoted by R.
Uh,
Um, that's all.
okay. Jay, please go ahead.
I think we can measure through confusion matrix.
How would you measure through confusion matrix?
Oh, no. Oh, yeah, so it measures the relationship between the independent variable uh, along the rows and columns.
So you mean confusion matrix will help you find correlation?
Uh,
Like,
yeah,
sorry, a confusion matrix will help you find a linearity between dependent and independent variables?
correlation matrix, I think, not confusion matrix.
A correlation? What correlation matrix?
So it says um, the relationship between one variable with another variable and forms the matrix along all the variables.
Okay. Yeah.
And diagonal is like the relation between with itself is one.
Okay. So yeah, here any answer on that? Yeah.
Yeah, so I was thinking about just basically visualizing using a scatter plot we can find. Also, there is this Seaborn library in which we can look at the heat map of all the variables, so we can use that. And apart from that, I think there's this thing called Pearson's correlation coefficient, so we can use that as well.
So yeah, guys, that is the word I was looking for. Now, correlation, there are different types of correlation. Pearson correlation in general, it measures the linear relationship between the variables. And so if let's say if there's a non-linear relationship, then Pearson correlation will not be a good measure to find the linearity between the variables. So that's why so when Akshit said correlation, my question was which kind of correlation. So the answer to that is Pearson correlation, and second is of course using scatter plot. Basically plot x and y, and you can see like if there's a linear relationship, then of course you can use that variable. So your point was, I mean, it's a good way of answering. Let's say, sorry, yeah,
Yeah,
Bhupesh.
I want to understand if the relationship is non-linear, then what should we use?
So let's say if the relationship is non-linear, that's where all this different types of decision tree, random forest, XGBoost, all these models, machine learning
Mhm.
models, which captures the non-linearity in your data. Those will
Yeah.
be,
Okay.
yeah. So coming on to the next question, if you see, we do take a assumption that there should be no autocorrelation between the residuals. How would you measure the autocorrelation? Uh,
We use the Durbin-Watson test to check the autocorrelation between the variables.
okay.
Uh, if it gives us the values between the range of 0 to 4, if the value is from a range of a 0 to 2, it says that there is a positive autocorrelation. If the Durbin-Watson test value output value is 2, then we say there is no autocorrelation.
Mhm.
And if the value is more than 2, then we say it's a 2 to 4, then we say it's negative autocorrelation.
What do you mean by positive autocorrelation and negative autocorrelation?
So the relation between the residuals value, the error which we get from the model, the relation between that variables, the
Uh,
variable value, each variable. So if we consider one variable in our model, then the errors one way error with other area, the relation between the two areas.
Two errors. Okay. What is the difference between error and residual? And
So
I would like to hear from Siddharaj also this answer. Yeah.
okay, so the error is the difference between the predicted value and the actual values, and the residual we say the values which is not defined by the model. The variables which is not defining the output of the model, that we call as a residual.
Residual. Okay. Siddharaj, can you answer that?
Yeah. So residuals are basically the actual data that we have minus the predicted values that our model predicts. So that is the residuals, and it is observable. And whereas errors are the difference between the true values, like the data that we have, minus the expected value of the true model. So true model is basically the best fitted model for our data, and errors are those, and they are unobservable.
Okay, so understood, Bhupesh. You just told the reverse definition, and also
Okay.
I'll tell you, I always used to thought residuals and errors are the same. But like after speaking to Sidira, that's where I realized it is different. So residuals and errors are different. Residuals are observable because it's nothing but actual minus predicted. Whatever, let's say you run a regression model, you get some prediction. You also have your actual value. So just take a difference. That's what your residual is. But errors in general, they are not observable. So if something is unobservable, that is what you say as errors. So here you had any better answer than this?
No, actually, I was going to answer the ACF autocorrelation measuring, so I raised my hand just for that.
Yeah, can you say that answer again? Yeah.
Yeah, so basically, autocorrelation is the reason for that assumption is because when there is some autocorrelation in the residues, that basically means that some of the pattern is still in those particular residues and not being captured by our regression model. And the way to exploit those particular patterns is by looking at the ACF plots that we can plot using the Python libraries.
Dude, this is very nice answer. Guys, understand this thing. ACF plot, and this is a concept which is taught in residual analysis of the time series models. But it is the same concept which is also used in linear regression. See, when you plot the residuals, when you do the ACF plot of the residuals, and you see certain, and there's a significance level, right? And you see certain lags above that significance level. That's where you realize, okay, there are still some variances in the data that the model has not captured. So if you see that, you again have to make sure your model, you need to do something on the modeling side, drop variables, add variables, clean data, anything. And that's why, and make sure like the residuals, when you do the ACF plot, every line should come into the significance level line. So very, very important and very nicely put it. So that's right. So let's say, guys, I guess this homoscedasticity assumption, that there should be homoscedasticity or there should be no heteroscedasticity. So like, how do you measure that in a regression model? Yeah, Siddharaj.
Yeah, so to detect heteroscedasticity in our model, there are some visual tests. So we can look at the residual plot and see the pattern of the residuals, like is it a cylindrical shape or maybe a cone shape. So that's one way to visually detect heteroscedasticity. Another way is through a statistical test. We can use Bruce-Pagan test to check for heteroscedasticity in our model.
So when you mentioned if the shape is cylindrical or cone-like structure, what is your x and y variable? Sorry,
So
what is the x and y axis? Sorry, what is the x and y axis?
so y-axis are the residual values, and x-axis is the time stamps. So, oh, I'm sorry, the level of independent variables.
The level of independent variables. What do you mean by the level of independent
Uh,
variable?
I mean, if we have a independent variable x, then the values of x are plotted on the x-axis, and the y-axis as the residual values.
Okay, sounds good. Any other answer? I guess, yeah. Anything else which you guys want to highlight other than this? Okay. So the next question is, and how to measure normality in your residual in a regression model? Yeah,
So I think we basically use the QQ plot. That's the only method I'm aware of.
what is a QQ plot?
Uh, QQ plot is basically a visual inspection technique in which we try to see if the line that is being plotted uh, is diagonally at a particular level, and based on that we could conclude the normality assumption.
And what is your X and Y axis?
I'm not sure of the entire details of the technique actually.
Yeah. Do you know what's the full form of QQ plot?
No.
Quantile plot. Yeah, just for reference.
Yeah.
Yeah, Jay, please go ahead, Jay.
I think it like QQ plot measures if the distribution follows the normal distribution or not, and there is a 45 inclined line that shows the normal distribution, and the data which we measure if it is follows the normal distribution or not. So it is like it shows the pattern around the distribution of line. If it nears to that, then we can say that if it follows the normal distribution, and otherwise it don't follow the normal distribution.
But like, what is your X and Y axis?
That I don't remember.
Yeah, so that, see, guys, if you say something, I mean, this is just for here and there. See, when you say QQ plot, everyone knows, okay, QQ plot is the answer, and you guys are right on that. But if I am the interviewer, my next question is, okay, what's the full form of QQ plot, which is quantile plot, and then what is your X and Y axis? Everyone knows it's a straight line. If your residual goes like this, then it does not follow normal distribution. Any other way to understand normal distribution of the residuals? There's one more way.
Histogram. We
Uh,
can use
Hist-
histogram.
histogram. Yeah.
yeah, perfect. I mean, guys, just draw the histogram plot of the residuals, and if it's following a bell-shaped curve, then you can always say, yeah, it follows a normal distribution. So, last assumption: how do you detect multicollinearity in the independent variables? Yeah, Siddharaj.
We can use the variance inflation factor to detect multicollinearity. So above a certain threshold, above I think 10 WIF,
Mhm.
say that there's a high multicollinearity in our independent variables,
Mhm.
and between 5 to 10, we say that there's moderate level of multicollinearity, and under 5, we say there's no strong multicollinearity in our model.
Why do you think multicollinearity is an issue? Like, what if it doesn't? Let's say if the assumption is violated, what will happen?
So if multicollinearity is the assumption is violated, our R square is inflated, and we get a false value of R square.
Okay. Here, any other answer than this?
Oh yeah, so I was thinking, would it lead to overfitting of the model?
How?
Uh, so uh, so basically, with excessive correlation, I think the model tends to overfit, and we basically use the ridge and lasso regression, which will add a penalty term during the this when this multicollinearity assumption is violated, and it tries to deal with that.
Okay, yeah. I'm not sure if it can lead to overfitting, but are you sure on this? Does it leads to overfitting?
I think I had read about it somewhere, but I'll have to confirm it.
I think ridge regression is used to fix multicollinearity, and we also use ridge and lasso regression to work with overfitting. So I think yes, maybe multicollinearity can also lead to overfitting in our
Perfect.
model.
Okay. Yeah, that's a good answer. So Bhupesh, anything else you want to add?
Not anything else, but just that it will be difficult for us to identify the coefficient that is it is um, influencing the dependent variable, influencing the variables which is due to which we are getting the what is the relation between dependent and independent. So we get, due to multicollinearity, there is an inflation of inflated value of uh, inflated value of coefficient, due to which it is difficult to identify which variable is influencing the dependent variable.
Are you sure whether the coefficients gets inflated, or is it something like which variable is contributing to the regression model we
That's it.
won't be able to identify?
So basically, what I meant to say is that it is difficult to identify what is the influence of each variable on the dependent variable,
Okay.
and the coefficient will be inflated. So that's what I want to
Okay,
say.
perfect. Yeah, perfect. So let's say normality of residuals is what is one of the assumption. How, let's say if it gets violated, how would you address that? Like what changes will you make in the model?
Can you come again with the question?
So, okay, let's say, so you basically ran a linear regression model and you were
Mhm.
performing all this test and you saw that the normality of the residual, which is like the residual should follow a normal distribution, right? And
Mhm.
this assumption is not being, is being violated. So what changes will you do in your model? Or let's say what will be your next step? If you see that the assumption is violated, what is your next step?
So I can use differencing technique to change the distribution of my data from.
This is not a time series model, Bhupesh. This is a linear regression model. In time series, why you take differencing is so that because you have a ordered data, you have each time steps, so you in that it makes sense. Anyone else? Here, yeah, please go ahead.
Hello.
I'm not sure about this, but I was thinking, what if we try to increase the sample sizes? Because based on if we take central limit theorem into consideration, so that will basically tell us that with increase in the sample size, the distribution of the sample would uh, almost converge to a normal one.
Perfect. I mean, very good answer. This is one way, and the way you back to your answer is perfect by telling which statistical theorem is important in this case. So I agree to your point. Adding more samples to your data can be one of the ways. Any other ways which you guys can think of?
Removing the outliers.
Removing the outliers. Okay, yeah, this is another good way. Anything else?
Um,
We can perform PCA.
You can
which
perform a
one?
PCA. How would PCA leave? I mean, how would
Sorry,
PCA?
sorry, sorry, sorry.
Yeah, okay. So
Like,
he
was your question like how to remove this multicollinearity, or it was something
no,
else? I heard half of your question.
Shojan, man, what are you doing?
Sorry, sorry, sorry.
That question has gone. How do you address the issue of normality between the residuals in a linear regression model? Yeah, here, please go ahead. Here, any other way which you can think of? I see your hands raised.
Actually, I think it was raised
Oh,
from the previous one.
okay. So few other ways. If let's say, what you can do is using weighted least square regression.
Yes.
So what happens in a weighted least square regression? Let me tell you. See, let's say you have residuals, right? Then what you say is those places where residuals are high, I would give less weights to them, and those where residuals are low, I would give more weights to that. So this is a modeling technique in which you can make sure, okay, when you apply a weighted least square regression model, your residuals follow a normal distribution. Also, one more thing, what you can do is, if let's say your tests are getting violated, yeah, then that's a signal that, okay, the linear regression model is not a good model to use. Then you can shift your gears to
No.
non-linear regression models. But Yeah, man. I mean, these are
Um,
certain ways. Yeah.
the box-Cox method.
Yeah, so basically what happens, yeah, that's right. So the box cost transformation is nothing. It's a power transformation that actually helps you to stabilize your residual.
Stabilized.
So that's, yeah. So that's also a good way. Yeah, right. So let me revise. So adding variables, and when you say sorry, adding data, more data points, and you can back that answer with the central limit theorem. Second is removing outliers. Third is using weighted least square regression model. Fourth is box Cox transformation, and fifth is using a non-linear regression model. So moving on to the next question, how would you address the issue of autocorrelation in the linear regression model? So let's say you found, okay, the autocorrelation is not constant. How would you or let's say you found certain, so what's the assumption? Can you guys tell? Okay, first tell what's the assumption and how would you address that assumption of autocorrelation? Yeah, he.
I'm not completely sure about this methodology, but I have heard of the differencing method, and I think the ARIMA and the ARMM time series models use this to deal with the autocorrelation thing in the data.
But how would ARIMA or any time series model help you with this autocorrelation thing?
So there is this component which there is this component in that time series model which tries to deal with it.
Which component?
That I'm not sure about.
Okay. Answer is right, but explanation is, I mean, it's lacking. So I cannot say, okay, you are right. I need
Yeah.
a good explanation. Yeah. Anyone else? Yeah, Siddharaj, please go ahead.
Uh, Even I had the same answer. We can use an AR model to fix the autocorrelation.
Yeah.
Um, but
How?
yeah. Um, so I mean, the AR model helps us use the previous lags uh, in our model. So
Okay.
I'm
Okay. So, okay, guys, let me answer this. Okay. But yeah, your point, Siddharaj, that makes sense. Okay. Little sense. Okay. But let me answer you. So assumption of linear regression on the autocorrelation side is there should be no autocorrelation between the residuals. This is the assumption of linear regression. What is the assumption of time series model? There should be how would you say, like, stationarity of a time series? Three assumptions, right? Constant mean, constant variance, and constant autocorrelation, right? So constant autocorrelation. So autocorrelation can be there, but it can be constant, is what it is trying to say. And that's why you see all this, you use all this different ARMA, ARIMA model and try to capture the lags. So that's where, so when this assumption is violated, so the answer is you can go to time series model, because time series do capture the autocorrelation part of the residues. The only thing is it says there should be a constant autocorrelation. And why does it say like that? So that you can stabilize your model. Good, you guys good? And let's say what if the autocorrelation is let's say okay, let me ask you afterwards. Okay, so the next question is how would you address the issue of heteroscedasticity? Yes, Raj.
Yes, so to address heteroscedasticity, we can use robust standard errors, and we can also use weighted least square or generalized least square methods to work with heteroscedasticity.
What is the generalized least square method?
So in case of heteroscedasticity, we use weighted least square where we know how the variance is changing over time or over the level of independent variables. But in cases where we don't know how the variance is changing, we can use a generalized least square estimator, which estimates a function, and that function is how the variance is changing. And similar to weighted least square, we transform the variables and then go through our model. So that's I think that's how generalized least square method works.
Okay. Okay. Any more answers on this? Yeah. Yeah.
Square root transformation and what was the other one? Logistic transformation.
Logarithm.
Yeah, don't say logistic, Akshay, that would be a blunder because logistic is it's a regression model,
Yeah.
right?
Okay.
So the answer is yes, definitely transformation techniques, logarithm, square root, cube root, power, no, not power, yeah, logarithm, square root, cube root. So you can use this bunch of transformation techniques to transform your variables and then work on regression model, and if that can reduce your variance. See, what happens is in heteroscedasticity, your variance is not remaining constant. So that's why, so this can be one method in which you are transforming your variables. Second method can be what you can do is you can remove your outliers. Sometimes why variances are high, because let's say you have some outliers in your data, and for those specific values, your variance are becoming high. So you can just remove those outliers in your data set. Third way of dealing with this using least square regression model. So where the variance, where the residuals are high, reduce that. Reduce the weights on that. So it will automatically give you a good residual analysis chart. So these are certain ways of dealing with all this. If you see any issue of heteroscedasticity.
Mehul, one question on this. So
Yeah.
when we are using weighted least square method, so weights would be equal in linear regression.
So you need to figure it out. See, now you need to make sure, like, so okay, I was working on a weighted least square method. So what I realized was it depends a lot on, again, on the case study. So we also had certain COVID data, and during the during when we were testing our model during the COVID data, we were getting really bad fit for the variances. So what we did was, for that specific data, we kept 0.2, 0.2 for that whole year. We kept zero point 0.2, and for rest of them, we kept zero point 0.8. So it's a way of saying, okay, give 80% weightage to these observations and 20% weightage to these observations. So that's how a weighted least square regression method works.
So
So
it depends on the data and what type of analysis we are trying to do.
yeah, but it depends. See, that's why when someone asks me
Mhm.
how would you fill a missing data point? People
Mhm.
generally out of grad school or undergrad school, what they'll say, oh, you can use mean median mode. I would say definitely you can use mean median mode, but it depends a lot on case to case basis. What kind of data you're dealing with? Again,
Mhm.
it's not just you can just fill in. You need to reach out to your business stakeholders depending on how much data is it missing. If it's missing 10% of the data, then it's a huge chunk of data for a variable to be missed. So you cannot remove all the data altogether. So you need to talk to the stakeholders. So that's what I'm saying. It depends on case to case basis.
Sure.
Siddharth, you raised your hand or something?
Oh, I accidentally did that.
Okay, okay.
But,
How would yeah.
just wanted to ask, do we say that our OLS linear regression model is a weighted least square model with equal weights? Is that a correct statement?
So generally, if you see linear regression model in general, OLS, or you take the other SKLN, the way they have implemented, right? Those are generally, every observation is given equal weights. Every observation is given equal weights, and that's why, have you guys heard about this exponential weighted moving average model by any chance? So in exponential weighted, so it's a volatility based model. Exponential weighted it's called UMA model, EWMA model. It's a volatility based model. So in that model, what happens is the weights, you can either increase your weights or decrease your weights exponentially. That's why the term exponential. So what will happen? Why do you want to reduce your weights or increase your weights exponentially? Is at this moment, I want to, give maximum weight to yesterday's observation and then reduce the weights to the oldest observation, because those does not make sense to me at the moment. So that's why people use all this different techniques. So to your answer, Zidraj, yes, we use equal weights in a linear regression model. Depending on case to case, you can use WLS, but again, there's an exponential weighted moving average model, again on different side of the volatility, but it's a model in which weights are reducing or increasing exponentially. So so does that answer your question? Okay. So how would you guys address the issue of multicollinearity? So you found, okay, two variables are multicollinear. How would you go? What's your next step?
PCA, the
Okay, what's PCA, Akshay?
principal component analysis. It's a dimension reduction method, so
Right.
which converts the correlated variables into new uncorrelated variables. Right?
Are you sure it converges the correlated variables to uncorrelated variables?
Yeah,
No, no,
as far as I remember. Yeah.
no.
Did I say it the other way around, or
I
was
don't.
it wrong completely?
No, no. What I remember was PCA. What it does is, let's say you have 100 variables, and if you want to reduce it to, let's say, 3 variables, because you don't want to model 100 variables, so you will reduce it to 3 variables, 3 principal components. So these 3 variables will capture 99% of your variance that is happening in the data set. Issue with what you said is, issue with this PCA technique is, you don't know out of what these 3 variables are. So you
Mhm.
lose the information on the names of these 3 variables. So you actually don't know what's going inside the model, because you don't know what is this principal component 1, 2, and 3. So, but your answer to tell you, your answer was wrong. PCA is not used for multicollinearity.
Oh,
But guys, tell me one thing: is PCA used now?
I
When I'm
think
thinking?
I think I've heard yes, PCA is also used for multicollinearity. I don't know how it is implemented, but yes, I think it is used.
So you're basically combining 2 variables into one.
I think we combine if you have, let's say, if you have 10 highly correlated, like there's multicollinearity in our 10 variables, then I think we can use PCA to change them to a single one variable uh, that can explain the variation in all the 10 variables. So just
But
a single list of just one variable, but that can explain all the data. And I think the data is also not lost or something. I'm
Hmm.
not sure.
Yeah, that makes sense, I guess. Then Akshay, like you are right on that. I mean, you can
yeah.
definitely use PCA, but the issue will be that only you lose on the information of. But again, if it's a
See, according to the definition on the QFE, it was PCA is a dimensionality reduction technique that transforms the original correlated variables into a new set of uncorrelated variables.
Okay.
You can use these components in regression model to mitigate the effects of multicollinearity.
Yeah, then this makes sense because we are using 2 components and making into one. Yeah, so I forgot this thing. So thanks for
Mm.
reminding me. And anything else, any other variables, any other ways in which you can think of dealing with
Um,
the issue?
We can drop
the
one variable and then run the regression model, and we can check what is output we are getting, and then we can check for other variables. That way we can see whether the multicollinear variables are what is the effect on it, which we can keep and which we can remove.
Yeah, perfect. I guess that's a great answer. Keep one variable and remove the other and run the model and check what's the output. Then keep second variable, remove the first, run the model and see what's the output. And whichever output is better, keep that variable. So yeah, correct answer. And anything else you guys want to say?
ridge
I
regression.
used,
Continue.
sorry,
Sorry.
go ahead, go ahead.
No, student, please say.
Um,
Yeah, I used this variance inflation factor in credit risk model, like to
VIF,
reduce dimension.
yeah, you are right. VIF is used to understand the multicollinearity. I understand, but the question is, how would you address the issue of multicollinearity?
Like if VIF was greater than 10, then we used to like either leave that variable or combine it with using that PCA.
Okay.
What they said, yeah.
Okay. And anything else you guys want to factor in? Any other technique?
The ridge regression.
How do you use ridge regression?
Um, I don't remember how, but um,
See, if you tell, you should give the good
yeah.
explanation. Yes, Raj.
Yeah, so legend lasso regression, they add a penalty term, right, to the cost function. So in case of multicollinearity, just a second. Yeah, so in case of multicollinearity, if we use legend lasso regression, the variables that are insignificant, those variables, the coefficients are reduced to zero. So in lasso regression, I think the coefficients are reduced completely to zero, whereas in ridge regression, they are brought closer to zero, but not exactly zero. And the variables that are significant, those coefficients are reduced, but they
Yeah.
are kept in our model.
So now let's say you have two variables which are multicollinear, right? And the issue is you run a lasso regression and give zero for both of them. So what's your next step? Will you remove both the variables?
No, we can use ridge regression in that case,
Yeah,
right?
ridge
So
regression will let's say it gives you small values for both the variables. Then would you just eliminate? How would you eliminate the variables?
we can check for significance, right? If one variable is significant and other is not, then we can keep the significant one. Or if both are significant, then I think we should use both the variables.
Okay, but see, guys, the best answer is keeping one variable running the model, keeping second variable running the model, check which output is better. And that's, I to be honest, that's the best way of dealing with it, because there's no better way. When you use PC also, it's good because you know, okay, the variable is the same, so you can actually use PC also. But what I genuinely, because in what will happen in lasso and ridge is, I guess it whatever it will give you, it will actually make, if it makes both the coefficient zero, so that is not helping us in any way out, right? Because anyway your coefficients are multicollinear, which means that the data is almost the same. So yeah, just yeah. But okay, moving on to the next question. What is lasso regression? Rishabh, let me ask you this question. Just kidding. Yeah, I'm just kidding. Yeah.
No worries. I actually don't know much about like ridge and lasso regressions.
Okay.
So
Yeah. No worries. Yeah. Anyone? I guess. Yeah. Akshat. Yeah.
So ridge regression is adding the penalty term to the cost function, which is equal to the square of the magnitude of the coefficient.
Okay.
That's ridge regression.
And like, what happens when you add this penalty function to your cost function? What happens?
The magnitude of coefficient decreases.
To what? In lasso,
It
does it?
will decrease to zero,
Lasso is
actually.
0 and ridge is I think it's 1 or it's less. It's not 0, but it's less.
Okay. So that's right. So what's the difference between lasso and ridge regression? Anyone? Siddharaj, yeah.
Yeah, so in lasso regression, we have the penalty term lambda and into summation of absolute values of coefficients, whereas in case of ridge, we have summation of squared coefficients. That's one difference in lasso and ridge. And also everyone has mentioned in lasso regression, the coefficients can string to exactly zero, whereas in ridge they come close to zero but not exactly zero.
Okay. What will happen if lambda is 0?
I'm not sure.
It will be a linear regression model.
Yeah.
Because if you see what is the
Yes.
const function is nothing but your linear regression model plus this lambda term, right? Lambda times this weights of all the summation of the weights. So when lambda itself is 0, so this whole second term becomes 0. So what is your first term? It's nothing but your linear regression model. Yeah. So let's say what will happen if the values of lambda is very small or very large? What will happen?
If the values of lambda are very large, I think our model won't capture the data accurately. I think we can say that our model will underfit if lambda is too high, whereas in case if the lambda is small, then we can say it might overfit. Not sure.
Just think, guys, think little bit, think what will happen. So Siddharth, you mentioned, okay, the cost function you mentioned correctly. So when lambda becomes very small, what will happen? What do you know? What is the what does lambda does? What does it do? Do you know?
It's multiplied with the coefficients, right? So if the lambda is close to, it's very small, then our coefficients will be close to zero. So our all of the uh, independent variable, the coefficients for our independent variables would be very small. So
Okay.
uh,
Are you sure on that?
uh,
So,
I think so.
Okay.
so
Yeah.
I think lambda is the controls the strength of the penalty function.
Right. Right.
Sorry, penalty. Yeah,
But what?
and if it's I don't know.
I think I said it the other way around.
Here, where are you? We want your answer. Are you still with us? Have you left our chat? Okay, Bhupesh, you know this answer?
No, I only cannot say complete answer, but what Siddhiraj was saying and Akshit was saying, that it has influence on the coefficient because we penalize the values. That's what I know. I don't have a complete answer for this.
Okay, guys. So when lambda is 0, that means no parameters are eliminated. When lambda is infinity, every parameter is eliminated. So what happens in general when so this is you should remember when lambda is 0, then it means no or let's say when lambda is small, no parameters are eliminated. So basically what you can say is uh lambda is lambda is 0 means it's a linear regression. Lambda large means all the parameters are eliminated. Lambda very small means very few parameters are eliminated. So what happens if very few parameters are eliminated? Let's say you had a lot of different 100 variables and only few variables are eliminated. What will happen? Guys, tell me.
Uh, could you repeat? I think I lost connection.
Okay, so let's say if lambda is very high, all the parameters will be eliminated, right? So what will happen if most of the parameters are eliminated?
Model will underfit because there's no detail to capture.
Okay, and when lambda is small, what will happen?
If there's if our model was overfitting, then yeah, it will overfit.
Right, yeah. So something on that sort which you guys can look into. But yeah, this is one important question that I was actually asked in one of the interviews. I screwed up badly back then. But yeah, this was like one common question which was asked me. So I guess pretty much we have covered linear regression model. Okay, can R square be negative?
No.
Uh, are you sure?
Um, yeah, because R square is SSR by SSE, and Since it's a sum of squared terms, then how could the squared terms be negative?
No, so actually R square can be negative, Siddharaj. Now the question is how? Anyone? Did you guys know this? Can R
I, I don't know the complete answer, but it is something related to intercept.
what intercept?
In linear regression, we have an intercept if the model is overfitted and there is no intercept terms. Consider something like that. I don't have a complete answer, but I read somewhere.
Okay, so guys, please read this. Okay. So the next question is how would you evaluate the performance of a linear regression model? Yeah,
Visually we can do it using the residual plots, and R square is obviously the coefficient of determination. It will explain to us the proportion of variance that is being explained. And there are also different metrics such as the mean squared error or the mean absolute error.
Yeah, that's right. So what you guys can look into is adjusted R square, root mean square error, mean absolute error. This is one thing to look at. Second thing to look at is the p-value. P-value of all the variables. If just make sure like the p-value should be significant, which means the p-value should be less than 0.05. Third thing which you should look at is the standard error of the variables. If you see any variables has really high standard error, then that means you need to either but let's say if the standard error is high but still it is significant, then you can keep it. But you know that if the standard error is high and the p-value is also non-significant, then you can drop it. So these are certain ways to deal with or to understand the performance of your linear regression model. I'm just curious, what is R square? What do you mean by R square? Yeah, Siraj.
R square is also called as goodness of fit measure. So we can get a understanding about how well our model is fitting by looking at the R square value. And the formula for R square, I'm not sure, but I think it's SSR by SSE or 1 minus SSE by SST. I'm not sure about the formula.
Okay. So are anyone else who wants to tell this answer?
R square is a measure of how well independent variable uh, explains the variability of dependent variables.
Okay. Shivani, yeah, please go ahead.
So R square tells you about the goodness of fit, and R square is equal to SSE by TSS or 1 minus SSR by SST. And the one which you asked about negative R square, I'm not sure, but I can give a try. Like if we have if we get by any chance negative correlation, then negative R square is the possibility.
But we get so many negative correlation, right? I mean, correlation, I mean, there can be situation wherein you might have negative correlation, but the R square is still positive. So,
Okay. Yeah, I'm not sure about that answer, but yeah, for
okay.
R square, yeah.
Yeah. So R square, as you all said, goodness of fit. So what R square captures is the variance in the data, how well your model is able to capture the variances that is occurring in your data set. So that is what R square captures. Now the next question is, let's say I add a variable in the data, in your model. The R square increases, but the adjusted R square decreases. What does that mean? Siddharaj, by any chance, do you know this answer?
Could you please repeat the question?
Okay, so let's say I added one. So let's say you had 10 variables in your data set. You basically built a linear regression model on that. So once you add another variable, which is the 11th variable in your data set, what happens is your regression, the R square in the regression model, it increases, but the adjusted R square decreases. So what does that indicate? Should I repeat the question?
No, I got it.
Yeah,
Yeah.
yeah, but Siddharth,
Yeah,
were you able to hear?
someone was at the door, so I was
Oh
in.
yeah. Should I repeat the question?
Yeah, please. Thank you.
Okay. So let's say you have a linear regression model, in which you had 10 variables. So now you added one more variable, and you saw that the R square increased, but the adjusted R square decreased. Why does that happen?
Because if we are adding variables, then the sum of squared errors or sum of squared residuals will increase because we are adding one more variable. But adjusted R square is R square divided by n number of variables. So I think if as we are increasing the number of variables, the denominator is increasing. So adjusted R square value might drop.
Right.
So there's a small increase in R square when we increase the number of variables. There might be a drop in adjusted R square in
Right.
that case.
So guys, this is a very important question. Remember, see what happens is adjusted R square, it will always penalize those variable if in case the variable is not able to contribute. So that's why in this case, the adjusted R square decrease because the extra variable that you added is not able to contribute in the model. But why R square increases is because the more number of variables you'll add, the R square will go, increase. But the adjusted R square is a better way of understanding whether adding variable was helpful or not. So yeah, that is a good answer. So uh so what is a p-value? If like can someone tell me in easy words, how would you explain a p-value? Yes, Idraj.
P-value is a probability measure that we can use in statistical testing, in significance testing.
Okay, like can you give an example?
So when we check for the significant, if our variables are significant or not, we look at the p-values and we check if the p-value is less than alpha, which is usually 0.05. So that's one case where we can use p-value.
Okay.
Uh,
Right. No, that's a good answer. So I guess most of my questions are completed. A few more questions I have, one or two. How would you do feature selection in a linear regression model? Let's say you have 50 features in the model. How would you go about feature selection?
One way would be by significance testing. We can see which variables are significant and include those variables in our model.
Okay.
Um, another,
Ye-
uh,
Yeah, Jay.
Maybe in this we can use correlation metrics of all the variables.
Yeah, perfect. Pearson correlation is what you can use to understand if the variable is not contributing, you can actually drop that variable. So anything else? But you guys are right. I mean, these two are mostly used, Pearson correlation and just use p-value to understand that. Okay, one last question, and that's where we can end. What is the difference between correlation and causation? Have you heard about the term causation? Okay, yes, Siddharaj.
Yeah, so correlation tells us the relationship between two variables, if it's positively correlated, negatively, and also the magnitude depending on the correlation value. Whereas causation tells us how one variable affects the other. It explains the one-way relationship between the variables. So in terms of correlation, we just know that the two independent variables are correlated, but we can't say that one variable is affecting the other or the other is affecting the one. So whereas in causation, we can see which variable is exactly affecting which variable.
Actually, you know what? In the middle of your answer, I just wanted to clap, but dude, your answer was on point. So causation tells you cause and effect. If one variable is causing and affecting the second variable. See what happens. Let's say you have three variables, A, B, and C. What happens is you are capturing the multicollinearity between A and C. So what is happening is, let's say A is affecting B and B is affecting C, right? So in correlation, it can happen that okay, A and C are good, they have good collinearity, but that doesn't. But if you see this middle relation, it's missing. That is what has been captured by causation. Like causation will tell you, okay, A is affecting B and then B is affecting C, and that's why you see, okay, why C is getting affected by B. So this is very important. So just remember, this is the main difference between correlation and causation. So guys, that is, yeah, Jay.
I wonder if we have like any metric for measuring causation.
Metrics, I guess you can use causation, like there's a test which you can perform basically to understand if one is affecting the other, to capture the cause and effect.
Okay.
Yeah. So guys, any other questions which you can think of on linear regression? I guess whatever I had, I actually asked you. Any more questions which you can think of?
Yeah, just want to like have a doubt on that, how we can describe as a what is the difference between time series analysis and linear regression.
Okay. So what happens in a time series analysis? That's a good question. Actually, that's a good question. So what happens in linear regression? What you will do? See, first, let me tell you similarities. Both are using regression model only, right? In linear regression, what is happening is you are regressing against other variables. You are regressing y against x1, x2, x3, all these independent variables. But in time series, what is happening is you are regressing your y with the previous, either the previous value of y's or the previous errors of the model. So that's the only difference. But in the end, you're using a regression model only in both the cases. But what is happening in the linear regression, you're regressing against other variables x1, x2, x3. But in time series, you are regressing against the past values of your target variable. That's it.
Right, understood. Thank you.
Any other question, guys? Yeah, Risham.
Also, I had a question about the F test. Like, when do we use F tests in regressions, basically? Like, because I know about the T test, but what is the difference between using T tests and F tests?
Dude, anyone wants to answer this?
I'm not sure about this, but I can try. So I think t-test, we use t-test to test the significance, to perform significance testing for a single variable. Whereas when we are testing multiple variables or multiple scenarios, I think f-test is used in that case.
Yeah, so that is right. F-test in regression compares the fit of different linear models. Where unlike if you see t-test, it can only assess one linear regression coefficient at a time. So actually that's a good question. I actually forgot that. So I guess after hearing with Siddhiraj, I was able to recollect. Yeah. So that's a good answer. Yeah. So that's it. Yeah. Sorry, Siddhiraj, please go ahead.
For t-test and f-test, I've also read about LM statistics. So is that very relevant or used highly when it comes to linear regression?
What is LM statistics?
I'm not sure, so I just wanted to ask.
Dude, no man. I mean, I've never used it in practice as of like at least in last 4 5 years. But yeah, I'm not sure what is LM test here.
It must not be that important in case of linear regression.
Okay. So any more questions?
Uh, it was there in my syllabus actually, just a little part, but maybe LM test is something related to parameters which are restricted in the regression. something related to that, or those are which are like violated, maybe. I'm not sure, but yeah, I have read somewhere. Yeah.
Yeah, I'll just have a look. Yeah, thanks.
Yeah, let's look after. I guess it's called Lagrange multiplier test, LM test. Yeah, I'm just searching on the site, so maybe we can all go back and see. It's a good thing to know new things. So cool, guys. Thank you all for joining, and let me stop recording.